Precella, and I'm here with my brother Anthony Precella. We are going to look at factoring today in our, I wonder what a white error, that's not good. That's not good. Let's try all over, okay? And remember, you can access the assignments right here through Canvas. You'll see where I'm pointing that says assignments, but as I've told you before, I prefer accessing through My Lab and Mastering, and I open it, and
at that point you have your Pearson gradebook also.
Here's the Pearson gradebook. You use that gradebook to review tests and quizzes. Okay, that's how you review tests and quizzes through the.
We'll have a video,
Gradebook.
an announcement with a video showing that later on.
But now we're going on assignment number 4, factoring, and I've already taken the opportunity to check off these videos. And I had an email that a student was asking, were they supposed to watch the videos that were being recorded that I uploaded to YouTube from Monday, or can they just watch the videos in the homework? You can just watch the videos in the homework. Heck, if you can do the stuff without watching the videos,
Still gotta click them.
You still gotta click them. But did y'all find the?
You have
Let's
a
go
21
back.
score on that. So
Look at this. Under announcements, did y'all find? Here it is. The link to class lectures on YouTube. This link.
I hope the playlist is growing at this
It better
point.
be,
Okay.
The syllabus discussion, square roots, complex numbers, And after today, I'll take the video we're recording now, and it'll come down here in the next one, okay? And do y'all know what those numbers are at the beginning of each video?
That's the date.
The date designed to make sure everything, if we sort alphabetically, that falls in the order in which they're recorded. 2024. The year, 01 the month. Instead of 22 here, what are we going to put today?
Oh, 10. You don't need
24,
to add
that's
that.
right. Okay.
Our sister sometimes gets so annoyed with him, but he's going through, repeating and go. Yeah. Okay, so at 2:30, make Mama a cup of coffee and put some heavy cream. She should have about a quarter cup of heavy cream in it.
So the coffee has to be real strong.
And she says, I know that. I do that every day. Why do you tell me this? And I'm like, okay.
I'm just reinforcing.
Okay.
Okay, so here we go. And I'm switching. Do you want to say something about factoring?
Yes, I want to say something about factoring. We've already foiled this semester, and I'm going to do some foiling right now. 5x minus 7 times 2x minus 3. If we foiled that out, we'd get a 10x squared.
Remember, last time when we were foiling those complex numbers, the I squares became what?
Minus.
Okay,
Yeah,
okay, but
But
here
no
it's just
eyes,
a
it's
variable.
just
There's no
X.
eyes.
So 10x squared minus 15x is outer, minus 14x is inner, negative 7 times negative 3 is a positive 21. That's last. So we have first, outer, inner, last. And on this one, we can combine the outer and inner terms. There's no other like terms. There's nothing we can combine with the 10x squared. But negative 15x plus a negative 14x, that would be a negative 29x. And plus 21. In algebra, I'm not sure I've said this yet this semester, but it's something I'll say over quite a bit through the semester. In algebra, you always do stuff one way, foil it out, then you go backwards. Going backwards, that's what we mean by factoring. Today, if we were given this trinomial, 10x squared minus 29x plus 21, how do we go backwards to these two sets of parentheses? So
We're trying to write it as a product.
Okay, so there's this. Oh, so this first thing is the first one. This one right here is the outer
And
and the inner. That's an old and sign. And the last. You combine the outer and inner to get that middle term. Let me do one more. And you might say, well, wait, why is he doing that? I already know how to factor. Okay, 4x
Foil.
minus,
you already know the 4.
to FOIL, I mean, 4x minus 5 times, how about a
X
3x plus, what were you about to say, Tim? 7, okay. Foiling out, we have 12x squared first. Outer would be a 28x, a plus 28x. Inner, wait, I've gone first, outer. Inner would be a minus 15x. And last. Oops, L. Once again, we can combine the outer and inner terms, can't we? 28x minus 15x would be 13x. So here's our answer if we were just foiling. It would be 12x squared plus 13x and minus 35. L. This middle term is the outer and the inner.
I have trouble seeing that minus.
Oh, you're
Looks like
right.
M isn't coming through it.
We're going to have to go buy some more colored pens.
Mm-hmm.
So, how would we go about reversing the process? Given 12x squared plus 13x minus 35, how do we figure out 4x minus 5 times 3x plus 7? Well, there's a couple of methods. The only method I will ever use in this class or any other class is a trial and error method. We're going to just sort of guess at it.
It's also called reverse foil. Some books call it reverse foil.
Okay.
And that's a good description because you're reversing the foil method.
Given this, you've got to fill in these numbers and plus and minus signs. So it is sort of a trial and error process, but I'm going to give you a little bit of hints. If you're going in reverse, hey, y'all know this. What sort of numbers multiply together to give a negative number? 2 negatives, 1 positive, 1 negative, or 2 pluses? What sort of numbers multiply together to give a negative? 1 positive, 1 negative. So on this one right here, if this last number is negative, then realize it's the last 2 numbers here that are going to give you that negative 35. That means there has to be a plus and a minus there.
He'll summarize these sign rules in a moment, okay? But all you need to see now is if that last sign is negative, to get a negative product, you have to have 1 plus and 1 minus there inside the parentheses.
What sort of numbers multiply together to give a positive number? Either 2 positive numbers or what? 2 negatives. So on this one, we want a positive 21. Well, it could either be positive 7 and positive 3 or negative. How do you decide which one it is? You look at this sign right here. Now I'm about to summarize all of that with one of my world famous tables. Okay? And that's why I wanted to start here, because I want the table up at the top of the page as I write. Okay. Oh, a little terminology, by the way. When we're looking at a trinomial like this, it's certainly a sensible assumption that this first number will be positive.
Because if it isn't, we change it so that it is.
Okay, and you'll see that, if not before the end of class, then
Monday.
Okay? But we'll assume this first number, the coefficient on x squared, is positive. So with that in mind, my terminology, I call this sign right here the first sign, and this one here, the plus that I'm pointing at, second sign. So what we'll say is, if the second sign is plus, the factored form has 2 of the first sign. Now, what if this second sign is negative? What did y'all say? What sort of numbers multiply together to give negative? A positive and a negative. So we'll have the rule if the second sign is minus, 1 plus and 1 minus. So here's my table. Factored form. Let me see. I don't want to say it. Oh, you know what? I messed up again. My table. I say again because last year I did the exact same thing. The first column should be second sign. The second column will be factored form.
That factored form will be the answer that you're looking for.
So summarizing what I was saying about those second signs. If the second sign is a plus, the factored form has 2 of the first sign. It's factored. If the second sign is plus, yeah. Here,
It's the second
sign is plus. The factored form has 2 of the first sign. And that factored form certainly has 2 minuses. Now, what about if the second sign is negative? If that second sign is negative, like right here, negative 35, then what does the factored form have? 1 plus and 1 minus. So I'll say 1 plus and 1 minus. I'm going to make 2 more columns of this table. Now this is my preference. If the second sign is plus, then fill in those signs immediately. You have 2 of the first signs, I'll fill them in immediately.
That's the nicer case. That second sign being plus, you know what those signs inside the parentheses are going to be.
Either plus, plus, or minus, minus. Look at that first sign and that'll determine it.
Now, this one here,
when you have 1 plus and 1 minus, I like to wait to fill that in. Because I'm not sure if the plus goes in the first set of parentheses or in the second. If you don't like to wait to fill it in, just fill it in and you might have to switch it later.
That's what I would always do. I'd always just assume, okay, the first one's plus, the second one's minus. And
that's
then
fine when you're on a board where you can just
easily
erase.
But now
on ink like this, I think I'm finally convinced him to say wait to fill it in.
You have.
And now one other thing, if you're going backwards, this middle term, that's going to be very important. You got to combine the outer and inner term to get that middle term. If the second sign is plus, then notice how you're adding these 2 numbers, and that gets you the middle term. If that second sign is minus, like the 28 and 15, we didn't add those and get what, a 43? What were we doing? You're subtracting. Okay? So to get middle term from O and I, the outer and inner, if the second sign is plus, you're adding the numbers together. If the second sign is minus, you're subtracting. And like all things, it makes sense once you know how to do it. So if you know how to factor, this table is great. If you don't, what the heck is it saying? Just bear with us, and we'll start doing some examples. Okay?
Tony wanted to start with the minus one first, but I convinced him he should start with the easier situation of plus.
So we're going to do problem number 1. There was an X there because I think I was showing someone something the other day about, and I tried to get it wrong after class or something, I remember. It says factor 2w squared plus 9w plus 9.
Oh, goodness, that's one of those things. If I ruled the world, the first law would be X. Unless it's a multi-variable calculus course, all variables in algebra classes must be X. This W and stuff, but until I rule the world, we're stuck with these different letters. You're right.
So, is it clear what we're going to try to do? We got to fill in those two sets of parentheses so we can FOIL it out and get 2w squared plus 9w plus 9. How do we do that? Well, first thing I do is always look at these second signs. If the second sign is plus, 2 of the first sign. So I'll fill it in immediately. I know they're both plus plus.
Remember, first times first. When you're FOILing out, that's going to give us back this first term here, 2w squared. What times what will give us 2w squared? Well, w squared is easy. W times w. We're going to have a w in the first term there and right there.
What numbers?
You're thinking of positive integers.
Class. If I say what numbers, I'm not talking about fractions or decimals. I want positive integers, just counting numbers. What numbers multiply together to give 2? Don't say 4 times a half. I only want counting numbers. Okay, so I'll write out 1 and 2. So that's it. So I'm going to try this. W times 2w, or 2w times w.
Last times last has to equal 9.
It's impossible to do this without constantly foiling the stuff in your head or on paper. W times 2w, does that give me 2w squared? Yeah. What about numbers that multiply together to give 9? I'll get started. There's 1 times 9, and what else? 3 times 3. Well, you're going to have to try one of those pairs. You're going to make it work out. Oh, wow.
Oh,
That student years and years ago.
well, do it first and then explain.
Okay. We got to make this thing work out to get 2w squared plus 9w plus 9. So, sort of as a general rule, if you have several pairs of numbers, usually I start with the numbers that are closest together on the number line. And I'm going to start with the 3 and 3. I'm going to put a 3 here and 3 here.
If I have no idea which one is correct, I generally start with the closer pair. Okay?
The smaller number.
What's the difference between 3 and 3? 0. But 9 minus 1, that's a difference of 8. So I tried, unless I have a feeling, and having done this for 40 years, sometimes I do get that feeling. I guess I've only been teaching at 37, right?
Yeah.
But still, as a student, you get a feeling, oh, I don't think that's it. It's this one up here. But here, I think it's going to be 3 and 3. Let's check.
If I combine the outer and inner terms, if I FOIL this out, would I get 9w? We know that first times first gives 2w squared, and the green stuff, 3 times 3 gives 9. To decide if this is right, we got to see, are we getting the 9w? If you were FOILing this out, 2w squared, then a plus 3w, and a plus 6w, is that going to give me the 9w that I need? Yes.
Remember, if that second sign's a plus, you're adding the outer and the inner. That's what he's saying to do. The outer and inner have to be added. Do they give you back that 9w? And yes, they do. Now think about FOILing. Suppose...
Let me go ahead and... I probably won't do this always. But there it is, all FOILed out correctly.
So if we took this w plus 3 and 2w plus 9 and FOILed it out, we'd get 2w squared plus 9w plus 9. Suppose we had 2w plus 3 written first, and then w plus 3. Suppose the parentheses were reversed. If you FOILed that out, would you still get 2w squared plus 9w plus 9? You're going to have to type this into my math lab. If you typed it in the second way, would you still get the correct answer? Yes, you would. Multiplication is commutative. As long as you have the same thing inside the parentheses, the order of the parentheses doesn't matter.
So
I could type either one of those, and my math lab would accept the answer. Any questions there? So we come over here. I hope we're not getting logged out or for timed out. You see, they have parentheses here, but that's really for an ordered pair. I wouldn't use those parentheses. As a general rule of thumb, I don't use the hot buttons unless it's something that I can't do from the keyboard easily. Parentheses are right there on the keyboard. What are we going to put in? W plus 3.
Close parentheses, open parentheses, 2W plus 3.
There.
Notice how he's not hitting the space key. Don't hit space keys. Don't use capital letters.
There's never a time with Pearson MyLab that you should be using capital letters or hitting spaces.
Now, if it's been a long time since you've taken some algebra, you'll have to work harder on this than someone that
took math
371
last semester.
The last chapter, chapter 5 of 371, is all devoted to this factoring. So we're trying to review this pretty quickly. Let's see, problem number 2. Let's see, what is that?
This is the one Tony wanted to start off with, and I said, no, let's start with an easier one.
12x squared minus 7x minus 10. Okay? Oh, wait. I need to tell y'all something that
Do I need to stop this recording?
No. Okay. Before we do this one, here's a rule of thumb that helps sometimes. Okay?
Wait, let me switch over here.
Okay, I'm writing out a sentence. There should be no common factors
other than 1
in the parentheses other than 1. No common factors in the parentheses. Like looking at this answer here, what's the only number that divides into 2 and 3?
The only number that divides evenly into 2 and 3 is?
Say 1. 1's the only number. There shouldn't be, like this one here. If when you're trying to factor something, if you had 2x plus 10.
That can't possibly be right. 2 and 10 are both divisible by what number? What number divides evenly into them? 2. They're both divisible by 2. That can't happen.
What about this one? 12x minus 15. Could you ever have that as a correct answer? What number divides into 12 and 15?
3.
3.
Mm-hmm.
Okay?
If it's factored correctly, the only thing that can divide evenly into those numbers is 1. And that'll help you when you have a lot of possibilities for the first and last options.
What about something like 12x plus 5?
Would that be okay? What's the only number? Is there any number other than 1 that divides evenly into 12 and 5? No, that would be okay.
Okay?
So with that in mind, let's go to number 2.
That might help us arrange some of the numbers.
Did I see a hand?
Hand go up?
I don't think I saw a hand. I thought I saw. I think it was a drink going up. Okay.
12x squared minus 7x minus 10.
Well, wait.
Show them the table first. Second sign is minus. So that means we're going to have 1 plus and 1 minus. I'm not sure whether the plus goes in the first set of parentheses or the second, so I'll wait to fill it in. So I'm going to draw my 2 sets of parentheses. And I'm going to make a note there's going to be a plus and a minus. But again, I don't know if the plus goes here or here. I'm going to wait. I know that the first two terms should multiply to give 12x squared. So what numbers multiply together to give 12?
Do you agree there's going to be an x and an x in the first term of each set of parentheses? So the real question is, what multiplies together to give you 12? Well, 1 times 12, 2 times 6. Is there another one? 3 times 4?
Now, I'm going to do the same thing with 10. Numbers that multiply together to give 10. 1 times 10, and there's another one. 2 and 5. And now it's just a matter of trial and error until you figure out the one that works. Okay?
I think that we need to look at that statement that you have right here, because I think we can discard one pair of numbers. There can't be common factors inside the parentheses other than 1, okay? Do you agree, looking at 10, both of these pairs has an even number. 10 is even, 2 is even. Or look at this 2 and 6. Both of those are even. So if you use 2 and 6, 2x and 6x, you're going to have to either pair the 2 with a 2 or a 2 with a 6. Are y'all following my logic?
We tried 2x and 6x. This isn't going to work because we could have put the 2 here or here.
So 2 and 5 wouldn't work. You can't put the 10 there or there.
In general, you cannot have two even numbers in the same set of parentheses.
So I can discard 2 and 6, just thinking my way through that.
I'm going to try 3x and 4x.
And why are we trying that? Unless you already have an idea, let's say these numbers were real big. That 12's pretty big, you know. Multiplying 12 by something, I would think we'd get a pretty big number in the middle. So that middle number isn't that big. So I agree, try the pair that's that's closest together, 3 and 4. Does that always work? No.
But if this 7 were 72,
I'd try 12.
Maybe the 12 would work, because we need some big numbers. Okay, so we tried 3 and 4. I'm going to try to pair it first with the 2 and 5, and if that doesn't work, I'll try it with the 1 and 10.
And if that doesn't work, well then try it. Maybe I'm wrong. Maybe 1 and 12 is what we need.
No, if I'm going to pair it correctly with the 2 and 5, can I put the 2 right here? No, because you cannot have two even numbers in the same set of parentheses. So I'm going to try the 2 here and the 5 here. Now, let's look at the outer and inner.
Go back to that table, remind them.
Oh.
If that second sign's a minus, the outer and inner have to be subtracted to give you that number 7, to give you that middle term. So let's see. What's the outer product?
Should I do it?
Oh, you do that. Yeah, do that like
horizontally. I think I liked it the way you were writing it horizontally the other day. So what did you do? You said, okay, so 12x, I'm foiling out 12x squared, and then we have a 15x.
I thought I liked it better the way you did it.
And an 8x. If I'm going to get a negative, first of all, if I subtract those, does that give me a 7? Yeah. So how do I need to arrange my plus and minus? If I want to get a negative 7, then I think the 15 needs to be...
If we're going to get a negative 7, the 15 needs to be negative.
The 8 positive. If I have it like that, that would combine to give a negative 7. But how would I need to arrange the signs in order to get a negative 15 and a plus 8? Where does
Deal
the plus
with the negative 15 first. Where do you put that minus so you get a negative 15x when you're doing the checking the outer and inner? Right here, okay.
And a plus.
So where did the 15 come
Okay, I'm foiling out. I'm not showing the, well, okay, I'll show the first. That'll give me 12x squared. Okay?
Outer.
Squared. Then the outer was just a 15. We hadn't put the plus and minus in yet. Entered just an 8. We hadn't done the plus and minus. And the last was 10, but now we know it's negative 10. Did that answer the question? Do you see where the 15's coming from?
Maybe you should do the little brackets.
I think I will on
for
the
the
next
next
one.
one. Yeah, I
Okay.
think that's it.
And so
I only have one, and so
years ago, the student, I mean,
you're just
literally,
making this work.
it was around 1992. Y'all weren't born yet and stuff. And I had a hostel student. I haven't had a hostel student in years and years and years. But he was a hostel student, and he said that to me during class. You're just making these things work out. And, oh wow, how do I diffuse a hostel student? Oh, that is brilliant. You are right. I'm just making these things work
And that's
out.
what you're doing.
I'm going to remember that and tell every class that. You're making them work out. Now, the rest of the class is laughing and stuff because he didn't mean it as a good thing. He was a hostel student, but, I mean, literally, 30-something years later,
You're
I'm
making
still
it
thinking
work
of that
out.
student.
You're making it work. That's what you're doing. You're making up a FOIL problem that'll give you back the thing you started with.
That's why we're only using numbers that multiply together to give 12. You wouldn't want to use, a 5x and a 9x. That would give you 45 for
You
the
want
first
12.
terms. You want 12. You're making it work out. Okay? Type it in so they'll feel confident that I have to.
Does it matter if I typed 4x minus 5 first and then the 3x plus 2? Do you think they'd give me credit for that? Yes, they would, as long as you have the same sets of parentheses. Watch, I'm going to type the 4x minus 5 first. And then what was it? 3x plus 2.
Now, X that out, and it's possible you go through all of this stuff and you can't factor it, okay? That's what that option prime is. Sometimes it'll say prime, sometimes it'll just say not factorable, okay?
But if you went through a prime number is a number that can't be written as a product other than 1 in itself. A prime polynomial is one that can't be written as a product other than 1 times itself.
What are the prime numbers? 2, 3, 5, 7, 11, 13, so forth.
Now, number 3?
No, 4.
Okay.
And then I'll just sort of jump around. Number 4. Let me write that one down. Ooh, 20b squared.
There's one thing I see about this problem that I like. What do I like about this problem?
The second sign
is
positive.
So we know the signs in the parentheses. We're not going to have to wait, try to figure out where does the plus go, where does the minus go. We're able to figure it out we know the signs. May not know anything else, but we know the signs inside the parentheses.
And we know numbers that multiply together to give 20 and numbers that multiply together to give 15.
Yeah.
So, there. Okay, so the second sign is plus, so 2 of the first sign. Second sign is plus, 2 of the first sign. I'll fill them in immediately. So draw my 2 sets of parentheses. Second side is plus, 2 of the first, so plus, plus. Oh, now.
And do you agree we're going to need a v times v to get that v squared? So we know the variable part of the first term. The problem is that 20. What times what will give you 20? 1 times 20, 2 times 10, 3, no, 4 times 5, 6, 7, 8, 9, we're back to 10.
What about 15? 1 times 15 and 3 and 5? Well, it's a matter of how fast you can find the pairs. Here's what I think I'm going to do. I'm going to start with 4 and 5 and try it with 3 and 5. Okay? By starting it with that, I mean I'm going to put 4v times 5v. Now I'm going to try it with 3 and 5, and if that doesn't work, I'll try it with the 1 and 15, but when you start multiplying 15 by either 5 or 4, that's going to get you a pretty big number. So, how should I try it with the 3 and 5? Can I put the 3 here and the 5 right there? Say no. If I put a 5 right here, what number other than 1 divides into these? A 5. So just like we said, we couldn't have 2 even numbers in there. You can't have 2 of the same numbers. 2 same number? No, you can't have a 5 and a 5. Can't have that either.
Well, then they're both divisible by 5.
So that means if it's going to work, I better try the 5 here and the 3 there. And now I need to FOIL it out in my head.
Well, you know, first times first is going to, first times first is going to give you the 20v squared, and last times last is going to give you the 15. You wouldn't have written those numbers down if it didn't. So all you have to check is the inner and the outer.
And look at how the marks I'm going to do. I'm going to put this little green mark here, and right there I'm going to multiply the 4v times 3. That's a 12v. Then I'm going to make another little mark here for the outer.
No, that's the inner.
I mean, for the inner. I've already done the outer. Now the inner, 5 times 5v, that's a 25v. So these two numbers add together to give that middle number. Yeah. I've done it. Okay, I've made it work out. 4v plus 5 times 5v plus 3. Let's see how I got that. There's a lot of thought going on here. Okay? A lot of thought.
And some luck just by starting with the closest pair. Okay, so
Started
there
with
is
the 1
some
and
luck.
20.
For some reason, I was thinking go with the 1 and 20 first, just because that number right there was pretty big.
So
I thought
20 times 3,
20 times,
5,
yeah. I was thinking 20
15.
times 1. That would have just been 35, not 37.
Yeah,
But my first thought was, oh, I bet we need the 1 and the 20. No, we didn't.
Okay.
I
type it in.
Yes.
4v plus 5 times 5v plus 3.
So left parentheses, 4v plus 5 times
5v plus 3.
And if you type an X, you'll get the wrong answer. You have to use the variable that they have in the problem.
And I just want to make sure, is it clear what I'm doing with these little marks here? This is my outer and inner. That's all that matters is outer and inner. Does that give me a 37? I know for a fact that the first is giving me a 20v squared because I only use numbers that multiply together to give 20. And the last, the 5 and 3, they're going to give me the 15 because I only use numbers that multiply together to give 15.
What about number 5?
Yeah, let's do 5 now. Six x squared minus 13x plus 3. Draw my two. 6x squared minus 13x plus 3.
He can fill in something immediately. What can he fill in and be 100% certain he's right about it? Okay. Wait a minute. The second time to plus. So
what am I going to put? 2 minus. Since this second sign is plus, that's what I think are the easier ones. Okay, so minus, minus.
Well, I don't think it's just you thinking. They are easier.
Yeah, I think that. Number 6, multiply together to give 6.
And we know the variable part here and here. What's that going to be? What times what gives x squared? X. So you know you're going to have an x there and there. What about the numbers in front? Well, what do you want to try?
1 and 6, or the 2 and 3.
Well, try the 2 and 3. We've been trying the closest pairs, so let's try.
I'll put a 2x and a 3x. Now, there's not a lot of possibilities for that 3. I guess I could have filled in 1 and 3 first, but I didn't. So, with it like this, how should I arrange it? Could I put the 1 with the 2 and the 3 here? No, you can't have the same number. So, I'll try it like this. 1 and 3.
Now make your little marks to check the outer and the inner. I think you're going to be close, but
6. Positive 3. So let's see.
All you got to check is the outer and the inner.
This is a negative 2x.
It's hard to see that negative.
Oh, negative 2x and a negative 9x. Do those combine together to give me a negative 13x?
Negative 2 plus negative 9 is negative 11. He's close, but that's not it.
Okay, so what do I do? Okay. Well, there's nothing. There's no way that 2 and 3 can be working then, or can work, can it?
So we're going to have to switch to 1x and 6x.
1x and 6x.
Mark that one out.
Oh, let me mark this out. 1x, I'll just write x, times 6x.
And you know the signs.
Oh, wait, yeah, I do know the signs.
So
second sign's a plus, so 2 of the first. So let me put minus and minus.
okay, what do you think? Can we put 1 here and 3 here? 1 and 3. Can we put 3 right there where my pointer is? No, because then 6 and 3 are both divisible by 3. So if we're going to use 1 and 3, we better put
3 here.
Mm-hmm.
And 1 there.
Yes. Oh, wow.
Oh,
I wasn't expecting that.
what's going to
Okay.
happen here?
Check the outer and the inner.
I know the first gives me 6x squared, and I know the last gives me the 3. But if I check the outer and inner, I guess this is one of those times when I should say, are we sure I didn't miscopy the problem?
Yeah, let's
Whenever
check.
this happens, that's the first thing I always think, oh, let's check and make sure.
6x squared minus 13x plus 3. No, that's it.
What are we trying? What's going to happen here?
Are we going to get back that minus 13x?
We'd have a minus, the outer, is that a minus 1x?
What's
And
the inner product?
That's an inner. Is that a
Negative
negative 18x? Do those add together to give me negative 13? No.
We've gone through every possibility.
So there will be an option that says either prime or not factorable. Which
And
one does it say?
prime.
Oh, I'm
So
going
we're
to write both. Prime,
Oh, wait.
not factorable. There's no other way it could be. Okay.
So let's see. Select prime. Check. Sure enough. Okay, I didn't see that.
I thought it was going to work with the 2 and 3
Me
and the
too.
1 and 3. Oh, wow. Anyway, okay.
Let's do number
no,
6.
7.
7? Oh, 7. Right there.
Jim, you know what? We weren't doing number 5. This is number 6 right here.
Oh, my God,
Sorry.
Tony. Did I go too far? What? Or
That's
did you
number
say?
6.
That's number 6. You're right.
So let's go back and do number 5.
Oh, well,
I
okay.
have here 2 number 5. Let's see, is 5, okay, yeah, no. Does 5 have a second sign of plus or a second sign of minus?
Oh,
This is a good one.
Okay.
Okay, I'm glad this is number 5. The one we just did was number 6. I don't know how.
So change that, mark that out. It looks funny the way you have it written.
Oh. 6.
Okay, so the one we just did was number 6. Now we've backed up to number 5. Okay.
Let's see. 3r squared minus 3 minus 8r.
There's something I dislike about this problem, even other than the fact that it's an R and not an X, okay? There's something else I dislike about this problem. For our process to work, the polynomial you're trying to factor must be in descending order based on exponents. The biggest exponent term, the exponent, just the first power, and then the constant term, no variable at all. So that's what I dislike about number 5. Here we have the biggest exponent, r squared. What should be the second term? Okay, so we have a 3r squared minus 8r, and the last term is the minus 3.
So you've got to write it in standard form. R squared, R constant. Constant is what we call a number that doesn't have a variable on it. And if you look back, like x squared, x constant. V squared, V constant. W squared, W constant. Here when we were forming it, notice it ended up in the form x squared, x constant. So you've got to have it in that standard form. That's going to be important for the next assignment also, okay? But I always have these polynomials written in this standard form. R squared, R constant. Now, let's see.
What do we know about the signs? Is it nice like 4 and 6 where we can just fill them in immediately? No.
Second sign is minus, so 1 plus, 1 minus. But there's not a lot of numbers that multiply together to give 3.
Mm-hmm.
And if you're sitting there thinking that idiot, there's infinitely many numbers that multiply together to give 3. Again, when I say numbers today, I mean counting numbers. Okay? 9 times a third will give me 3, but I'm not talking about fractions. So just 1 and 3. Let me draw my 2 sets of parentheses.
Make a note, you're going to have 1 plus and 1 minus.
That's what I did.
And we know the variable part for the first terms. To get an r squared, you have to have a r and an r. So, oh, well, heck, there's only one possibility for 3r squared. So
just an r and a 3r. Let's try that. And
only one possibility for 3. Could I put the 1 here and the 3 here? No, you can't have those 3 r's. I mean, the 3r and the 3 because they're both divisible by 3.
Yeah, you can't have 2 of the same number in the parentheses. If this is going to work out and not be another one of those prime, then the 3 is going to have to be there and the 1 there. The only common factor we have now is just a 1.
Okay. Check the outer and the inner. Multiply the outer and the inner.
Okay, so here's the outer. I would have just a 1r. Then the inner. What would I have for the inner product here?
9r.
What I'm doing, 9r.
And remember, when that second sign's a minus, these terms have to subtract to give you that middle number. The outer and inner are going to have to subtract.
If we subtract these numbers, can we get that middle term, 8? Yeah.
9 minus 1 will give us the 8. So now we have to figure out how to put the signs.
So I want a
so we get a negative
8r. The bigger product, the bigger one, has to have this sign. So the 9 would need to be negative and the 1 positive. Notice how I'm working backwards, making this work out. So in order to get a negative 9r, what would need to be right here in this first set of parentheses? A minus and a plus. We'd have a negative 9r plus 1r, giving a negative 8r. We've made it work out. Sometimes students start thinking, wait, this is the answer. No, the answer are the two sets of parentheses.
Any questions there?
Again, these little marks down here, what I'm doing is I'm foiling, but I'm not showing the first terms, because I know r times 3r is 3r squared. I know 3 times 1 is 3. All I'm interested in is, does the outer and inner terms combine together to give that middle term? Middle term has to be from the outer and inner. Okay? So outer, 1r, inner, 9r.
So, left parentheses, r minus 3, and right parentheses,
3r plus 1.
3r plus 1.
I've already done 5.
How about 8?
Let's do 8. Okay. Okay, good. I wanted to do another one with a minus. So good. Number 8.
3w squared minus 5w minus 12.
Is it in the standard form that we need it to be in order to
Is
factor?
this like that number 5 where we have to move the stuff around? No, it's in the order we want. Descending order. Variable squared, variable, no variable.
Well, what about the signs? 2 pluses, 2 minuses, or one of each in the factored form? I know that there's 2 minuses here and here, but what are we going to have in the factored form?
Wait.
Oh, wait. So what are we going to have? Second sign is minus, so what sort of numbers multiply together to give a negative?
Okay, so we'll have 1 plus and 1 minus in the final answer.
Okay, well,
At least that 3 isn't bad. It's only 1 times 3.
remember years ago I had a student in Math 371 who on day 1 told me, there used to be a Math 370, an arithmetic course. On day 1 she told me, it took me 5 times to pass Math 370, so I know it's going to take me at least 5 times to pass this course. I'm going to repeat you every semester until I pass. And so, okay, fast forward a couple of years. We're doing this. She's still in the class. We're doing this, and she says, stop right there, what I'm doing right now. And it was the number 12. 1 times 12. What other numbers am I going to write here? 2 times 6 and 3 times 4. She said, the reason I can't pass this class is I don't know where you're getting these numbers. And she had a big calculator, and she said, look at what I do. I type 12 into the calculator, and it won't give me these numbers. And inside, I sort of cried a little. I got her a multiplication table, the old-fashioned multiplication table printed out, and suggested maybe she wants to try studying that's her problem. She didn't know the multiplication tables. And afterwards, I went on down to my boss at the time and said, I'm ready to take a break from Math 371. And that's been, 15 years?
Yeah.
And I'm still on break from it. Okay. But anyway, there's no way around to do this if you don't know your multiplication tables. And if you need one, we'll print them out. If it's been a long time since you've multiplied, okay, you just got to study those. That'll make this much easier. Without knowing the multiplication tables, it's almost impossible. Okay? So, not a lot of possibilities. 1w times 3w. What pair of numbers do y'all feel like trying? 4 and 3? No, I like the way you said 4 and 3.
Can we put the 3 here? If we're going to use 4 and 3, can't put the 3 there. Y'all see that common factor thing really decreases the number of possibilities
Look, if
you
you're
have to
going
check.
to try the 2 and 6, you can't possibly put the 6 there.
You could only put the 2 there.
And what about 1 and 12? Could we have put the 12 here? No, all common factor. So 4 and 3, I'm going to put the 4 here, the 3 here, and let's see if we can make it work out. Putting in our plus and minus, can we get a negative 5W? So I'm going to make those marks. This is the outer, and that's 4W.
W times 4 is 4W. The inner. 3 times 3W is?
9W.
Okay.
That little table I keep pointing at and stuff.
It took me a while to get the hang of that table of yours.
Can I subtract the outer and inner terms to get that middle term? If I subtract 9 and 4, do I get a 5? Oh, yeah. Okay, so let's chase the plus and minuses. Let's go backwards and figure out how do I arrange the plus and minus. In order to get a negative 5, the bigger product would need to be negative. If I had a negative 9 plus 5, does that give me a negative?
No, negative 9 plus 4.
Negative 9 plus 4, does that give me a negative 5? Yeah. So what goes in front of this 3, a plus or a minus? A minus. And right here, plus. A lot of thought goes into this. Okay?
Even for the ones that you get right the first time and don't have to mark it out. There's still a lot of thought going in there. That's how you got it right the first time without having to cross it out and try something else. Any questions there? Okay. And once again, the order of the parentheses doesn't matter. I could type in 3W plus 4 first. Oops, no. I could type in 3W plus 4 first if I wanted to. And then the W minus 3.
And you can always check it just for and without.
And I want to warn you on tests. You think, if you accidentally typed X here for this problem, then okay, they'd say it's wrong, and I typed X instead of W. Okay, but on the test they don't let you do that, so you've got to be careful. Make it a habit. Study what letter are they using in the factor problem, and use that letter. I remember when I would teach this from a book at the board, it didn't matter what letter was on the problem. I'd write it up there on the board and I'd say, I think all other variables should be outlawed. I'm going to use X for everything. Can't do that. Here you've got to use the variable that's in the problem. I think number 10 was a good one.
Oh, wait. Okay, before we do number 10, I want to give a little terminology.
Wait a minute. Okay.
I'm going to define what we mean by a quadratic equation. A quadratic, even now I want to spell it out. Quadratic. An equation, I'm not defining what we mean by equation. And an equation is just a statement that has an equal sign in the original problem.
1 plus 2 equals 3 is an equation. An equation is just a statement with an equal sign in the original problem, of course.
A quadratic equation can be written in this form. AX squared plus BX plus C equals 0. This is where A, B, and C are numbers.
The letters
Let
are
them
X.
see problem 10, just to sort of see.
I'll let them finish right
Okay.
that.
But there's two types of equations that, well, I'm assuming at some point or another you solved what's called linear equations. A linear equation has just an X, no X squared.
Or W or P.
Okay, let's just pretend that you become ruler of the world and there's only X. Okay? But look at this with these W's. A quadratic equation has to have a square exponent. Okay? There's linear equations and quadratic equations.
Quadratic means the biggest exponent is a square. Okay?
Now, A, B, and C are numbers. You know what? I'm going to make this a formal definition. In order for this to be a formal definition, there's one number. If A, B, and C are numbers, there's one number A can't be.
We said there must be that variable squared. If A were 0, 0 times x squared, would we have an x squared term? No. So technically that A value can't be 0. The number in front of the x squared or w squared can't be 0.
Now,
because if it were, then we wouldn't have the x squared.
We can solve a quadratic equation by factoring. We're going to see several methods for solving quadratic equations on Monday. We can solve I'm going to say QE for quadratic equation by factoring. And here's how you do it. Step 1. Write it in standard form. By standard form, I mean
x squared x, no x equals 0.
Okay, like I think number 10, the first one we're doing, is already in standard form.
Let's look. Yeah, it's already in standard form. W squared, W constant, and 0. Oh, I haven't told him my idea to save the planet and to have us water. And Jacob thinks that, even if someone stole the idea from me and became rich with it, we'd all benefit.
Yeah, I know.
Mankind would benefit.
So write it in standard form and then factor. If I told you that I was thinking of two numbers and they multiply together to give 0, could y'all tell me what one of those numbers is?
0. The only way you can have a product equaling 0 is at least one of those things better be 0. So
third step, set each factor equal to 0 and solve for x. At that point, you have linear equations. By solve for x, I mean perform the opposite operation.
Oh, I don't know if this is really that great to write out, but I think just say solve for x, and then when you remind them of how to do it. Okay, I'm afraid it's going to get a little
too wordy.
Yeah.
Okay, let's do number 10. Let me write it down.
Oh, okay.
5w squared plus 29w
plus 36 equals 0. Do y'all see how that's different from the problem we just did? Look, here it has that equals a number. Notice it has an equals. 8. Look back at number 8. There's the problem. I don't see an equals a number or anything. So this is not an equation. Here your final answer is just parentheses.
Yes. That student at Bamboo Garden that said that his teacher was an idiot because he told him to study the instructions. No, that was about 1991, 92, and that's when I started thinking, I better start telling my students to study those instructions. If it says factor completely, your answer is going to be 2 sets of parentheses. If it says solve, like on number 10,
then your answer is going to be numbers.
They might be fractions, or they might be whole numbers. They're going to be numbers, and it's sort of important. I remember one semester, I think it was a year ago, the student was a great student, and oh my gosh, she took quiz 1 and did terrible. She was able to redo it, but I remember she came to me and said, what did I do wrong and stuff? And I looked.
Everything that said factor, she had gone ahead and set each factor equal to 0 and came up with the solution as if she were solving an equation.
She did more work than she needed to or than she was asked to do, and as a result, she got them wrong. So the instructions are important, okay? Very important.
Before any test or quiz, there'll be a review as one of the homework assignments, and The instructions there for the problem on the review will be the instructions that are used on the tests and quizzes. So,
And you can go and tell your teachers, friends, those idiots, they say study the instructions. Oh my gosh. I wonder what ever happened to that person, but anyway.
I don't know.
Okay.
But you're making me hungry.
Yeah.
Okay. Oh, wait,
Okay.
let me switch over. Let's get going.
So hopefully you see how this problem differs from number 8.
You still have to factor. You still have to be able to factor,
Okay.
but there's more to it. Once you get those 2 parentheses filled in, you're not through with the problem.
Is this one already in standard form? W squared W constant equals 0? Yeah, it's in standard form. So now we go on to the factoring. Well, okay. Second sign is plus, so
I see people sitting
Who's the
over there
first?
looking to this projector. You feel free to turn that table, okay? You feel free if you want to look at this projector, look towards this way, just turn the table.
It's good. I like writing sideways.
Oh,
Okay.
Okay, so second sign is plus, so 2 of the first sign. So there's going to be plus plus. I want to go ahead and write out the numbers that multiply together to give 5 and 36. Oh, a lot of those. 1 and 36, 2 times 18, 3 times 12, 4 times 9, and what else?
5, 6 times 6. Now, you see the way we write out these pairs, starting in numerical order, as soon as you get 6 times 6, you're on the other side, you've got them all.
So I'm going to draw my 2 sets of parentheses, put what signs in them?
Plus.
Second sign is plus, so 2 of the first sign.
And we know the variable part for the first thing. We know the letter's going to be a W, 1W and 5W. I can play it out in my head, and I know 6 and 6 isn't going to work.
If we put a 6 here and a 6 there,
Remember, what are we going to have to do to the outer and inner? We're going to have to perform what operation? Add. If I put a 6 there, that's 30. Right off, it's too big to be a 29. You could try the 6 and 6 yourself, but I'm convinced that's not going to work. That'll give us a 36W, not a 29W.
Now what about 4 and 9? Can I make this thing work out using a 4 and 9?
Actually, you can.
If I put a 4 here and a 9 there, when I do my outer and inner, am I going to get a 29?
What's the outer product going to be?
It would be
9W, okay. What's the inner product going to be?
9W plus 20W. Oh, wait, I guess if you're wondering why did I make my marks, I may as well. 9W and 20W.
Can we add 9W and 20W to get 29W?
Yeah. So we have it factored, but we're not finished. Here's the new part of the problem.
We've done steps 1, made sure it was in standard form. We did step 2, we factored it. Now here's the new part. The only way something times something equals 0, the only way it's going to equal 0 is for one of those somethings to be 0. So either W plus 4
is 0,
or 5W plus 9 is equal to 0.
Now what we've done is we've gone from a quadratic equation to two linear equations. How do I know it's an equation? Well, there's an equal sign, and there's no exponent. That's called a linear equation. So to solve a linear equation, you isolate the variable by doing this opposite operation to both sides of the equation. If I want to get this W by itself, what's the opposite of adding 4? Minus 4. So subtract 4 from both sides. I think I'm about to get my first answer. W equals -4.
This equal sign is like a balance, one of them old-fashioned scales. He took 4 pounds away from the left side to maintain the balance. He has to take 4 pounds away from the right side. So we found the first number, solution, -4. If we plugged in a -4 there and there and simplified, we'd make the left side equal 0. Circle that -4. No,
Oh,
just the
just
-4. Because all you're going to be typing in is -4. So I'm not
last semester I had a student
that
typed
did
in
the W equals X equals.
and every one of them was wrong. Oh, let me look at that. And I went through and I took off 1 point, I think, from it, or I changed it so she got a little bit off, but she didn't miss every problem. I go in here. Isolate this W by performing the opposite operation to both sides of the equation, beginning with addition and subtraction. The opposite of adding 9 is subtracting 9.
Okay.
I'm hoping y'all aren't. I've discovered that my sister gets easily alarmed. I hope you're not out there like my sister. Oh, whoa, I've never seen this. -4 on both sides. Somewhere along your math, you placed in this class, so you've seen it. Now, this operation is 5 times W.
You know something that I like to do, Tony?
Huh.
When I do that, the stuff on both sides, I draw my little bar. I think it just looks better.
Oh.
9 minus 9 is gone, so you just have a 5W. 0 minus 9 gives a -9. Or maybe that doesn't look better.
Now, what would I do to get, I'm trying to get the W by itself. What's the opposite of multiplying by 5? Divide by 5. If some of y'all have had any,
y'all recall seeing this somewhere? To give us the
W
second number.
equals -9 over 5. Oh, I'm sorry, I ran out of room there. Y'all see what I've done? Any questions? So we have a -4 and a -9 over 5. When you're solving an equation, you're going to have numbers as your answer.
There's something called the fundamental theorem of algebra that we don't teach in this course, which seems strange, but still, it says that the number of solutions you get can't exceed the biggest exponent. So I guess you could have had the same number as a solution, but generally the exponent is a 2. You're looking for 2 solutions, and you found them, -4 and -9/5.
Okay.
I'm going to come over and notice they've already typed the W equals. All you're typing in is the number, -4, and they say separate them with a comma, and -9. So I use the slash bar from my keyboard, just out of laziness rather than, oh no. Okay, I'm not going to use the fraction bar. I think if it's just number over number, I take the lazy way out and use that slash. But when we get to messier stuff, especially involving logarithms, that fraction bar is the safe thing
Jump
to
on
do.
down to 15.
15? Oh,
Yes.
you think we're ready to? Okay.
Oh, wait, no, let's do 12 instead.
Why? Oh, I see.
Yeah. No, okay. 12R. Why am I saying to do 12? No, 12.
There's something, we haven't even factored one of these.
Yeah.
There's one type of trinomial that's the easiest type to factor, and we haven't done a single one of those yet.
Well, why should we be sitting up here doing the easiest stuff?
Well, they're about to see it now.
I know.
Why are you using R and T?
Oh, my goodness.
That's an
R and R. Oh, my
Mark it
gosh.
out.
Oh, wow. You don't make those mistakes.
Oh, sure. I do.
12R plus R squared plus 32 equals 0. Okay? Well, Do I need to flip back to look at
Wait a
this?
minute.
Oh. Let me lift this up so y'all don't see that.
Mm-hmm. But let him see the steps. To solve a quadratic equation, you got to make sure the equation's written in standard form. That's the first step.
So r squared, r constant. We've got to have 0 on one side of the equal sign. Well, we have the 0.
Is the problem in standard form? No, what needs to be, which term should go first? R squared, right.
So I'll write r squared plus 12r plus 32 equals 0. Gotta write it in that standard form.
Some terminology. The number in front of the squared variable is called the leading coefficient. What's my leading coefficient there? What's that number in front of r squared? Just 1. The only thing that can multiply together to give you one positive integers, 1 times 1. This is called a simple trinomial. They're the easiest to factor. Okay? If that first number is 1, then that's the easiest type to factor. And you'll find that frequently, as we get into the messier stuff, where we have to solve quadratic equations, so many times I'm thinking of the square root equations and those rational equations. They ultimately reduce down to simple trinomials, so that's nice. But
so you'll notice this one's going to be a little bit easier to factor. We still got to come up with numbers that multiply together to give 32.
1 times 32, 2 times 16. Does 3 divide in evenly? No. 4 times 8. 5. Does 6 go in evenly? 7. 8. We're back to 8 now. So we've got all of them.
So I'll draw my 2 sets of parentheses.
We know something nice about those signs. What do we know about the signs inside here? Okay.
Sign is plus, so 2 of the first.
The second sign's a plus, 2 of the first signs. And we know the first term, here and here. No work to it. We know it. It's a simple trinomial, leading coefficient of 1. So just 1r times 1r.
With a simple trinomial, the reason we say they're the easiest to do is you can just look at these numbers right here and ask yourself, since it's a plus, which of those numbers add together to give that middle 12? Which of these numbers add together to give 12? 4 and 8, that's the one that works. And you say, well, wait, can we do that on the others? No, you can't.
It's only for simple trinomials, and there's not a lot of simple trinomials in the homework, okay? But when we get to the messier problems that we're having to factor, they'll pop up more often than you would think. So
I don't want y'all to get into too much of a habit to think that all you got to do is look at these numbers and see which
add them up and which
together.
one gives you that.
That does not work for something like this.
It doesn't work for anything we've done today except this one.
You can't say, oh, well, which of these numbers add up to 29? No. Okay?
If that leading coefficient is something other than just an assumed 1, you cannot make that assumption. You have to go through trial and error.
So we factored it. We wrote it in standard form. We factored it. Set each factor to 0. And isolate the variable. What will I do to get this r by itself? Subtract 4 from both sides. And we get r equals just a negative 4.
Okay. Now, there's another thing. Rather than just showing this minus 4, there's another way of thinking of it, and that's called transposition. I want Tony to show you that also. Transposing term says, okay, I want the r by itself. I need to get rid of that 8. You can pick it up, move it to the other side, but when you do, that changes the sign.
So what I did here with this minus 4, you may have had another teacher one time or another do this instead.
Bring it over, change the sign. Bring that positive 8 over, change the sign. You're going to
That's
get,
same as doing that. And why? Well, just making a little arrow was a little bit faster.
and
And I
I
guess
bet,
yeah.
you know, when I'm, by next class, I'll just be doing the transposing. Pick the term up, move it to the other side, changes the sign on the number. So -4 and -8. Any
Does it matter
questions?
which one you think?
Does it matter? That's a good question. Y'all tell me. Does it matter?
It
No,
does.
doesn't matter.
Type in a -4 and a -8. It doesn't matter if you want
Or
to
you
type.
can put in a -8 and then a -4, but separate them with the comma. Notice it already says R equals. All you're typing in are the numbers.
Now let's do 50.
Is that the hardest one, I wonder?
That's sure the last.
Well, it's the last one.
Okay.
It's not going to be the hardest one, I don't think.
Well, is it going to be a simple trinomial?
Nah, it's not a simple trinomial. What's the leading coefficient? 20? Yeah.
20c squared plus c equals 12.
This is where I really like transposing.
I know. I want to make sure that, like, on number 12, when I rewrote this, I didn't move anything across the equal sign. Is that clear? I didn't have to take the r squared and move it across, so I'm just keeping the same signs. It's a positive r square and a positive 12.
Notice you already had 0 on the right-hand side here on number 12. You already had 0 in the original problem. Here we have a 12 over there.
We need a 0. So what will I do to get a 0 over here? Okay, you subtract 12 from both sides, or doing that transposition, you can just say, okay, move the 12 over and subtract.
That positive 12 becomes a
Negative.
Okay. So 20.
Is it clear why I'm changing the sign on that number? But I didn't change any signs up here. The 12 stayed positive. They're on the same side of the equal sign. So here's what we're going to try to factor. 20c squared plus c and a minus 12 equals 0. So, y'all caught up with me? What about the signs? Second sign is minus, so one of each, a plus and a minus. Okay, so I'll write up numbers that multiply together to give 20. 1 times 20, 2 times 10, 4 times 5. Write up numbers that multiply together to give 12. 1 times 12, 2 times 6, 4 times 5.
Huh?
I mean, 3 times 4, 4 times 5. Yeah. So I'm going to draw my 2 sets of parentheses. You'll see this one's going to be a little bit more involved, the factoring versus this simple trinomial over here. Okay. As you got to figure out, oh gosh, y'all have since this middle number is going to be so small, 1c, I don't think we're going to be using a 20 or a 12.
I can use my trick. I can get rid of the 2 and 10 first because every one of these pairs has an even number over here, right?
And there's another pair you could get rid of.
Oh, you can get rid of the 2 and 6 also.
Could I have a 2 and 6? Because then there'd be no place to put these even numbers.
Did y'all follow my logic?
Can't be a 2 and 10 and a 2 and 6 because, okay, I'm going to start with the 4 and 5. 4c and 5c. By the way, I didn't make a note. Y'all said there's going to be a plus and a minus. Let me just make a note of that so I don't forget. I'm going to try. Do y'all see why we're saying it can't be a 2 and 6?
Because either the 2 has to go with an even number or the 6 has
and
to
they
go.
can't. Okay? So if we pair it with 3 and 4,
Can I put the 4 here? where my pointer is? No. If I'm going to try 3 and 4, I better put the 3 there. Better put the 4 there.
Wow, this is a lot of really nice analysis. So I'm going to go ahead and draw my little outer and inner marks. The outer is going to be, is that a 16C? And the inner is, what is that, 15C?
Now go back, remember that second sign there is a minus, which means you have to go down. So you have to subtract the outer and the inner. So
if I subtract 15 and 16, can I get this 1? Sure. So let's figure it out, the signs. We need a positive 1C, or just a plus C. How do I need to arrange the red plus and the red minus? Oh. Okay, so which one would need to be positive to be left with a positive? If 16 is positive, the bigger number has to have that bigger sign. Then the 15 negative. So in front of this 3, what do I put? A negative, and there a positive.
and there's a desire to just say, okay, I'm through with that one, but are we through with this problem? No, we got it. It's an equation.
So
When it says solve, that means you're looking for variable equals number or numbers. So what do we have to do?
now, 4C minus 3 equals 0, and 5C plus 4 equals 0. So on this one, I'm going to perform the opposite operation to both sides, beginning with addition and subtraction. The opposite of subtracting 3 would be adding 3. So we have 4C, over here the 3's are gone, so just 4C equals 3.
Or you could think to yourself, pick up the negative 3, move it over, it becomes a positive.
That's how I'm going to do the next one.
Oh, okay. And then what do we do to undo that 4 times C? Divide by 4. So we're using division at this point.
The 4's cancel. What number are we going to have to type in as our answer? 3 over 4. Good. Okay. Now, over here, you're subtracting 4 from both sides. I'm going to just do that. That's the lazy man way of doing it. You're saying, okay, 5C is negative 4. So just move the 4 over and change the sign. And then divide by 5. What's the next answer we type in? Negative 4 over 5. Now,
So-
I'm glad we have 2 fractions because I want to discuss how to type those in.
Okay. So we come over here. Once again, we'll have to use the comma to separate our answers. I'll just type them in the order in which we got them. The first one is 3/4, and then I put a comma. Is that what I want?
The comma should not be in the bottom of the fraction.
It used to be that if you typed a comma in the bottom of the fraction in this assignment, it was automatically counted wrong. But some little programmer decided, oh,
Let
let's
me fix it.
fix
and
it
throw a
so that
little
it'll
fix.
take the comma in the denominator. And they changed the programming on certain problems. So if you type it like that, and then you put, what's the next one? Negative 4 over 5. They'd accept it with that comma down there. The problem is that not all the problems were fixed to accept that comma in the denominator. And once we get to the cut point method next week or the week after, you put a comma in a denominator it's going to be counted wrong, no explanation, what have you. So my advice to you, you be extra careful. When you're typing these fractions in a comma, you should never have a comma in a denominator.
Notice how it's in that blue box. You know what, Tim? Erase everything and do it the correct way.
Oh, okay, that's what I'll do. Oh, wait. Okay, wait. I'm going to erase everything there. I'm going to have to just go like that.
Okay.
Okay, so what is it?
3 over 4.
3 over 4. You see where that thing is flashing? Do whatever it takes to get out of that denominator. I'll just use a right arrow. Okay? Notice it's no longer flashing in the denominator. It's beside the fraction. You put the comma and then negative 4/5. Do not put commas in denominators, even if the problem will. There are some that might accept it, but there'll be more that won't accept it. And when we get to the messier problems, and you're ever going to have messier stuff coming, you do that, it's just all wrong, and all your work was for nothing.
Yeah.
Any questions there?
What time is it? We have time to do one more. Let's do number 14.
Oh, really? Okay.
Yeah, just some messy looking numbers.
Okay.
20. Oh, wait.
Oh, 13 is one of the real easy ones. No, let's do it because it's a simple trinomial.
But on number 13, look back at it real quickly. Don't write this one down.
Don't write down number 13. It's a W square, so that means it's going to be an easier one to get factored. But what do you have to do? There's only one correct first step. Okay, minus the 16.
Good. Okay.
But let's look at number 14.
And while we have different numbers, your assignment will have different numbers the way it's randomly changing. But one thing isn't randomly changing. If on my number 13 I had to move a 16 over,
you're going to have a number here that you're going to have to move over also. Okay?
Mm-hmm. Number 14. So this will be our last example. 20w squared
minus 39w plus 18 equals 0.
Wait a minute. We have it already.
That does seem familiar. Have we already done this one?
What, those numbers? No?
No, well, I think...
No, it's a 20v squared plus 37b. Okay. Well, is it in standard form? Do I need to move anything around?
No, it's already in standard form. I know something nice about the signs. What do I know? Okay,
sign is plus, so we're going to have 2 of the first, so they'll both be minuses. Now write out the numbers. Sometimes students tell me, oh, I can do this without writing out those numbers. Well, I've got to show something. Okay, if I can do it in my head,
you're not trying to do the problem. You mastered all of this material decades ago. You're trying to explain to someone else how to do it.
So this is
what your thought process is.
I'm thinking of the numbers that multiply together to give 20. If you don't need to write them down, fine. Okay? I'm thinking of the numbers that multiply together to give 18. Okay?
Write your 2 sets of parentheses and put the minuses in there.
So second sign is plus, so 2 of the first. Mm-hmm. Gosh, well, your little rule, we can't use 2 and 10 because then we could have put an 18, we could have put a 2, we could have put a 6.
And so we can discard the 2 and 10. And if you don't follow my logic, just go home and try it using 2 and 10. Well, you either put the 18 with the 2, common factor of 2, or you put it with the 10, common factor of 2, so you can't allow that. Go through the possibilities to convince yourself that what I'm saying there is correct.
Which ones do you want to try, the 4 and 5 or the 1 and 3?
We're stalling to give someone a chance to get it done so they can call out which one to use. So we're just going to go with the 4W and the 5W. Okay?
Let's see. Do y'all want to try the 3 and 6? So, the 6 can't be with the 4. You cannot have two even numbers in the same set of parentheses. So if it's going to work like that, I'd have to have a 3 here and a 6 there. Now the only common factor is a 1 in each of these.
Okay, what's the outer product?
Y'all foil it out in your head, the outer and inner. We would have a negative 24 and a negative 15. Negative 24W, a negative 15W.
Remember, the numbers have to add together. The outer and inner have to add. That last sign there have to add to give you this number here. Do they? Yes, I think we got it.
Okay, so we factored it. Now let's set each factor to 0. And add 3 to both sides. Are y'all caught up with me? So we would have 4W, the 3's are gone. So we have 4W equals 3.
And then what do we do?
Divide 4.
Divide by 4.
So
And there's the first number. We'll type in 3/4.
And over here, move the 6. Or if you want to say plus 6, plus 6. I mean. And then divide by 5. So 3 over 4 and 6 over 5.
Any questions there before I type them in?
Yeah, I think, I know y'all are thinking this, and so I'm going to go ahead and answer the question. You're just afraid to ask. You're thinking to yourself,
Wait a minute.
Oh.
What do I have to do? There's only one correct thing I should type next. I should hit on the keyboard. What is it? What I need to get out of that denominator before I type my comma. So right arrow, comma, and then what was the other one?
6
over 5. Is that what I wanted to type?
Yes. Okay. Now, I know y'all are sitting there wondering, well, wait a minute. What if we had this
Wait, let me
equation?
switch back.
Remember that number 6, the one, if we were trying to solve this, 6x squared, suppose there'd been a equals 0 on this problem where it can't factor.
They can't see the problem there.
Well,
but remember, this was the
prime. It wouldn't factor. So if you're thinking, well, wait, if you stick a plus 0, how do we get the answer there?
Equals 0.
I mean, it equals 0. Well, you don't, not by factoring. We're going to see some other methods on Monday. So if you're sitting there worrying, what happens if it doesn't factor? How do we solve the quadratic equation? We'll have another way of doing it, okay? So you can stop that worrying right now. I don't want y'all to have your weekend spoiled worrying about that.
Any questions? I got to tell you my solution to the water problem, the water shortage, and it doesn't involve desalination.